Hi there, my name is Harriet, and in this video we're going to look at the processes involved in lake stratification. Have you ever wondered why oil doesn't mix with water? Or perhaps why a solid sinks right to the bottom of the glass, like these coins? Or maybe why your milk separates out from your hot chocolate? The answer to all these questions has something to do with density. Density tells us how closely packed together the particles are that make up these different substances. As you may know, in a solid the particles are tightly packed in a fixed pattern, which makes solids very dense. In a liquid they are packed close together but move freely, while in gases the particles are widely separated. Since the coin, as a solid, has very tightly packed particles compared to the liquid, when we drop the coin into the liquid, it displaces the water due to the strong pull of gravity and ends up at the bottom. In the oil and water example, even though they're both liquids, we can see that the oil is less dense than the water, which is why it sits at the top. And this is because of the different chemical makeup of these two liquids. But let's say the liquid is the same chemical makeup, but there's just different temperatures. So here we've got an example of colder water with some blue food colouring and warmer water with some yellow food colouring. And we've got a bit of plastic, preventing them from mixing. And let's see what happens when we actually remove this bit of plastic. So, as you can see, the two liquids actually stay separated to a large extent, and that's because the warmer water is less dense and therefore it floats above the colder, denser water below. So far we know that solids, liquids and gases all have different densities, and we also know that liquids can vary in density too, depending on the chemical makeup, but also on their temperature. And what does this all mean for lakes? Well, lake stratification, we now know, is just a fancy way of saying separated into different layers due to density. In the summer, when the surface water is warmed up by the air and the sun, we get warmer, less dense water floating above colder, more dense water. But let's say there's a really cold day in summer, and this surface layer loses heat to the air. What happens then? Then we've got a scenario where we have colder water overlying warmer, less dense water, and we can see what happens by moving this around. So let's see if I can do this without causing too much of a mess. So here you can see that there's a much greater degree of mixing going on, and that's because the colder, denser water which is on top, being pulled down by gravity, is displacing the warmer, less dense water here, and in the process there's so much mixing going on that the two are actually mingling and becoming one equilibrium temperature. And when it all becomes one single temperature, we call this isothermal. And this is what can happen in a lake. So what about a storm? Now a storm introduces another element that can cause mixing in a lake, and that is wind. Wind injects energy into the surface of the lake, creating waves and currents. And these act a little bit like taking a spoon and mixing up your hot chocolate until it's fully mixed. So now we know that there are two processes that cause mixing in a lake, which break down the stratification, that density stratification, and create these isothermal conditions. We're almost done now, but there's just one more thing I want to think about, and that's ice. So you might be right in thinking that ice as a solid should be denser than the water and should sink down to the bottom and accumulate at the bottom of a lake. But that's not what happens, is it? So we all know that ice, let's do this one. We all know that ice floats, and we may have seen lakes that are fully iced over. And the reason this is because despite it being a solid, ice is unique in that the particles are formed in a lattice shape, which is actually less dense than the water below. And that's one of the unique properties of ice. So thanks for listening.